Okay, so they want us to find I and Vx in this particular circuit, and they're giving us the initial current in this particular circuit. That is, it happened after the switch was disconnected. This is the initial current in the circuit. So I is basically the current going through the inductor, and the formula is giving us the initial current in the conductor times e raised power minus t over tau. Now tau is equals to R L over R A Q. Now we know what L is, but R A Q is going to be a bit tricky to find. You see, RA due to of all sources, but you see, of all independent sources. But you see, this is a dependent source. This is actually a voltage controlled voltage source. So it's controlled by voltage and it's a voltage source. And you can't turn this off. So we're going to do something slightly tricky, but it's allowed because it still obeys the rules of linearity. So at this particular portion, we're going to replace this place with a 1 volt battery. Yes, this is okay to do. And I'm just going to regard the current coming in here as, let's say, IO. When this IO current reaches here, is split into two branches, I2 and I1. Now we obviously know from KCL the sum of currents going into the branch, which is IO, is equal to the sum of currents leaving the branch. Now to write those equations, this is nodal analysis. If you don't understand nodal analysis, please refer to my former videos. So IO is basically going to be the voltage here minus the voltage here all over the resistor that is here. So the voltage at this point is actually 1 volt. It's going to be 1 minus, at this node, let's name this node VA. It's going to be 1 minus VA all over 4. This node and this node are actually the same because they are just connected by a wire. It's going to be equal to I2 is simply going to be VA minus 0 over 4. So it's VA over 4 plus, for this particular one, it's going to be VA minus plus 2Vx. This is a voltage source, by the way, so you can do this. So the V higher minus V lower. The reason why it's plus is because the sign starts with plus. So it's the normal V higher minus, then you have to include the sign. If it was minus then plus, then it's be minus 2Vx. So you have to be very cautious about the sign. It will be over 1. Now I'll simply multiply through the equation with 4 to simplify the equation. It's going to become 1 minus VA equals to 4VA minus 8Vx plus VA. We simplify this equation, then you're going to have 9 equals to 14VA. That means VA is going to be equals to 9 over 14 volts. Now the whole idea of this thing is that Req will be equals to 1 volt, that 1 volt over the current I that is passing through the 1 volt. So the current at this particular position, which is in this case is I naught. So if you can actually also put a 1 amps current source instead. It's actually a preference. So that means Req now be equals to the voltage at this position over that 1 amp source that you put there. This is V equals to IR, common Ohm's law. Just make R subject formula. That's just it. So that's just the whole idea of this thing. And yes, it's proven to work. Now to find IO is simply 1 minus VA, because 1 minus VA over 4, because it's the current flowing through this 4 ohms resistor here. This is going to be equals to, we have found VA to be 9 over 4. This is going to be equals to 5 over 36. Actually, sorry, over 56. So therefore, this is going to be equals to 1 over 5 over 56, going to be equals to 56 over 5. Therefore, tau, let's come down here. Tau is going to be equal to L over Req, right? So it's going to be equal to the inductor L, which is 2 Henry, over what is Req, which is 6 over 5. Simplify this, you're going to get 5 over 28. And now for the final thing of I is equal to what? Now is 5 e raised power minus t. In this case, we have found what tau is. Tau is 5 over 28. So it's going to be over 5 over 28. X is going to simplify to be 5 e raised power minus 5.60. And now lastly, we need to find Vx. Vx is simply, at this point, Vx is actually the voltage across the 4 ohms resistor. And in this case, we know the current passing through this 4 ohms resistor is what? I. You can see it here. So Vx should simply be equals to 4 times I. What is going to be negative, because look at the sign for of this. Look at the sign of voltage drop on this resistor going from here to here, which means the current is supposed to be moving in this direction, but this particular I is moving in the opposite direction, so it has to be negated at this point. It's actually this I that is being negated because it's moving in the opposite direction than what we actually want. So it's going to be minus 4 times. We have finally gotten this answer, 5e minus 5.6t. And so that's equals to minus 20 e raised power minus 5.60. This is your final answer. Thank you for listening. Hope you really understood this.